Okay, so I think the first thing we can do is identify where we're starting. What unit do they give us to start us with? Yeah, 52.76 moles of H2O. And we're supposed to go to how many, what? Molecules of H2O. So back on our chart, we're starting from moles of H2O, and we're working our way down to particles, which includes molecules. How many steps is our problem going to be? We're starting with moles and we're going to particles. This is just one conversion, right? One conversion. One number's got to go in the top left box. I'm sorry, what? 52.76, very good. Moles of what? H2O. And what unit should I put down on the bottom here? 1 mole of H2O. Now a lot of people get caught up here. They could follow to this step and they get lost here, and I want to show you why that's the case. We're starting with moles and working our way down to particles. We're going to do this step right here. This is the only conversion factor that we will ever use to go from moles, particles, particles to moles. 1 mole is equal to this many particles. 1 mole needs, or at least a mole of H2O needs to go on bottom. 1 mole is equal to that many particles. So on top we should put the 6.02 times 10 to the 23rd molecules of H2O. Notice that the term mole and molecule are not the same. Mole is not an abbreviation of molecule. Molecules are very small. Moles are somewhat large. I'll let you multiply this in your calculator and we'll check our answer in just a second. Make sure you're using the E button. 52.76 times 6.02 E23. If you do 10 carat top, you will. It's just I would encourage you to be mindful that could, if you don't put parentheses in the right spot, that could mess you up. 4 sig figs, so I need to choose 4 from my answer. 3.176 times 10 to the 25 molecules of H2O. Good? Feeling confident about this stuff? Okay. Do what? If you want to bring it to me real quick, I'll look at it. So in this problem, what are we starting with? 7.82 times 1027 what? Atoms, it says, right? So where am I starting at on this chart? Am I starting at mass, mole, or particle? Starting at particle. And what does it ask me to go to convert to? Moles. So I'm going to go up to moles. Agreed? How many steps is this going to be? Just one. Which am I going to use? Am I going to use molar mass or am I going to use the 6.02 number? Yeah, I would use this road to go between particles and moles. So we start out by putting on top the 7.82 times 10 to the 27th, and that's atoms of gold. That's AU. AU is the symbol for gold. And what should I put on bottom? 6.02, okay. Times 10 to the 23rd.
Just thought you might want to see. Dude caught him this morning. In the boys' restroom.
In this problem right here, 6.02 times 10 to the power of 23, and this is atoms, right? Of AU. And this would be equal to 1 mole of AU. So you'll notice what separates this third problem from the first two is that now we're reversing the direction. That's why the 6.02 ended up on bottom. So want to make sure that this flip here isn't an accident. It's on purpose because we're going the different direction. So now in our calculator we should put the 7.82 E27 times 1, which is still the same number, divided by 6.02 E23. You probably were able to get something like 12990, right? I have. So with 4 sig figs, I would say that we would go with, or 3 sig figs, I'm sorry, we might have to go with the answer that is 12990 would become, this 9 will bump him up, so maybe 13000 moles of AU. If you left it as 129,990, I'll probably give you credit anyway. But it can't be 130. There's a huge difference between 13,000 and 130. Your value has to be the same, or relatively the same, I should say. Cool? Good. I'll let you work on this problem individually real quick. Example 4. Work with someone around you if you'd like. It's going to read 10 to the power of 24. 4.82 times 10 to the power of 24. Molecules of C6H12O6, that's glucose or sugar. How many moles do I have? I'll let you copy this one down. Work with someone around you if you'd like. Let's see what we got. We got this question written down. This is going to be a little bit different. We're starting out with 4.76 moles of Na2SO4, correct? And we're going to atoms, right? So we would say that this is going to be just like we've been doing, where we're going from moles to atoms or molecules, right? But I'm asking about moles of Na, or atoms of Na. I'm not asking you about molecules or units of Na2SO4. So here's what you have to do that's a little bit of a trick. Since you want to know a part of a molecule, or a formula unit, a unit if you will, here's what we have to do, a primary step. 1 mole of Na2SO4 is equal to 2 moles of Na. This is a different step. Because inside of Na2SO4 there are 2 of them. Do we understand that? In the other problems, I've been taking from molecules, and this is a molecule obviously, and I was asking you about, this was atoms and this you had so many moles. Now I'm giving you a compound and I'm asking how many atoms are in it. It's a different thing. And for every 1 mole of Na, there is 6.02 times 10 to the 23 atoms. So when they give you a molecule, as they did in this case, and they want to know how many atoms, or formula unit is what it is, they want to know how many atoms you have to break it down. Do you see why I'm doing this extra step in the middle? Okay, so 4.76 times 2 times 6.02 times 10 to the power 23. With 3 sig figs in our answer, 5.73 times 10 to the 24 atoms of Na. Good. We'll work on more problems like that for sure this upcoming week.